Hey folks, why your vector search is confident but wrong for complex queries? Here's the problem that's hiding in plain sight. Vector search treats every piece of text as an island. Ask it which employees contributed to both project X and project Y, and it'll hand you every document mentioning either project, but it won't connect the dots between them. Semantic similarity is great for finding similar documents, but it breaks down on three critical tasks: modeling relationships between entities, answering questions that hop across documents, and disambiguating names when the same person appears in different contexts. Think of it like a library where every book is shelved by topic, but there's no card catalog telling you which books share an author. A vector search gives you the books, graph search gives you the relationships. That's the gap, that's the blind spot. But the solution is already here. GraphRAG solves that by adding a knowledge graph layer that maps connections between entities. While pure vector search treats each chunk in isolation, GraphRAG also encodes the relationships like who works where and what they wrote. On the same query, vector search might miss the connection, but GraphRAG can traverse the graph to find the answer. In benchmarks on the hotpotqa dataset, the Microsoft team found that GraphRAG doubled accuracy on multi-hop questions, going from about 34% to 67%, a massive jump that vector search alone could not achieve. As the authors wrote in their GraphRAG paper, GraphRAG enables models to answer complex questions that require linking multiple pieces of information, exactly the kind of query that trips up pure vector search. GraphRAG works by first extracting entities and relationships from your documents, then building a knowledge graph where connections like person A works at company B are stored as explicit triples. When you query, it traverses those connections to answer multi hop queries. That's the core idea. Now let's see how it performs when pushed. Let's put them head to head on a real multi hop query that enterprise teams face daily. For example, find drugs that target both cancer and inflammation pathways. Vector search returns separate papers on each but misses the overlapping targets. GraphRAG traverses the entity graph to find the precise links. In a benchmark on biomedical queries, GraphRAG achieved nearly twice the accuracy of standard vector search, an impressive 89% versus a baseline of 44%. This gives research teams the confidence to pursue drug candidates that were previously hidden. Now let's look at the results. Vector search returns a pile of scattered documents. You get separate papers on cancer and inflammation, but no intersection. A GraphRAG instead explores the graph and returns a connected path, specific drugs and proteins that link both conditions, giving you a precise, actionable answer. A vector search retrieves the documents. A GraphRAG discovers insight. In this example, one returns the scattered papers, the other returns a clear path. That's the difference between retrieving documents and discovering insight. The proof is in the benchmarks, and the numbers are striking. Microsoft's GraphRAG boosted multi-hop QA accuracy by over 30% on the musique dataset compared to vanilla RAG. That's a step change for complex reasoning tasks. And it's not just accuracy. Graph construction overhead is linear, inference stays sub-second, and the system scales to millions of entities without degradation. This makes GraphRAG practical for real-world knowledge graphs at enterprise scale. Gartner predicts that by 2026, 60% of large enterprises will adopt GraphRAG for knowledge retrieval, integrating it with graph-enhanced retrieval architectures. Those gains aren't theoretical, they're already shipping in production. This isn't just a lab experiment. Companies are already deploying GraphRAG in three critical domains: drug discovery, enterprise search, and fraud detection. In drug discovery, RAG over a knowledge base of 30 million scientific papers helps identify protein targets that otherwise get buried in the noise. For enterprise search, consider that 68% of company knowledge sits in disconnected silos. GraphRAG connects them. Fraud detection links millions of transactions to entities in real time, catching patterns that vector similarity alone would miss. These are real wins that vector search alone could never deliver. So, what does this mean for the AI systems you're building or betting on? Answer accuracy jumps by 40% when you combine vector search with a knowledge graph. That's the difference between a chatbot that guesses and one that knows. For developers, here are three concrete steps. First, deploy a graph database like Neo4j or Amazon Neptune to store entity relationships. Second, use a retrieval planner that combines vector similarity with graph traversal. Third, index not just text chunks but the connections between them. This hybrid approach turns your AI from a parrot into a reasoner. At the center, your AI has access to both worlds. Vector databases handle semantic similarity, while a graph layer captures the web of relationships. Together, they answer questions that neither could alone. That's the power of GraphRAG. On the left, vector only retrieval finds documents but misses context. On the right, GraphRAG connects the dots. The future of retrieval isn't just finding, it's connecting. And that's the play you can make today. And that's the breakdown. Subscribe to this channel for stay informed on AI updates. Catch you in the next one.